Hello, 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 hello. How are we all doing? Good to see you, Nat. May actually make a stream. Coding is way above me, so I won't have any idea what's going on. That's alright, you can just pop me in the background and listen to my dulcet tones as I drone on. I will have to have a quick break at maybe around 7:30. I've got a food shop delivery on its way. It'll be here between 7:30 and 8:30, so I'll have to stop for that. Also, my cat got neutered yesterday, and also had to have surgery for it. So he's curled up next to me on a chair in essentially a baby grow to stop him licking his wounds. So I've got to keep an eye on him, make sure he doesn't jump or move too much. But it looks like he's fairly settled at the moment, so that's nice. But welcome. I am currently drawing on GIMP, trying to demonstrate the success that I had off stream. It's a fairly big success. Essentially, I found a way of not only storing the hex tiles in a sensible fashion on a 2D axis, which is very handy. I also found a mapping from the hex coordinates to their vertices coordinates, and conversely a mapping from the vertices to the hex coordinates. So I will demonstrate that in just a moment. Yeah, let's hop on over. So this is how we're going to be storing the hexagons. I will stick to my adding of 2-digit numbers in primary. Don't worry, we might even get to multiplication today, let alone adding. As you can see, it's not that complicated. It's just a simple grid, 2 coordinates for each. The only weird thing to get your head around is these are the axes. So you've got one axis going along here. You can see the x coordinate increasing as we go along the horizontal direction. You can also see the y coordinate increasing as we go down this diagonal. So you can think of it as horizontal rows, so one here, one here, one here, one here, one here, and these diagonal rows as well. And then you get these coordinates, all unique, which is lovely. And you can essentially store it in a square grid. You're just going to be missing, where shall I do this? Missing a hex here, 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 and here. I think that's it, right? So then you've got 0, 0 here, 1, 0, 2, 0, 3, 0, 4, 0. You've got 1, 0, no, you've got 0, 1 here, 0, 1, 0, 2, 0, 3, 0, 4. And then you've got, what's this here? This is that right? Have I done that right? 4, 0. Oh, I've done 2 lots of 3 ones. Okay, I'll correct that in just a moment. This is 4, 0, 4, 1, 4, 2. This would be 4, 3, and this, I suppose it's more over here, would be 4, 4 in line with that, and then 3, 4 over here. So that all lines up very well. I've just been, get rid of those dots and correct. Let's draw a 4. Oh, that's pretty thick. I did increase the size. What did I have it at before? 10, I think. There we go. 4, 1. That looks better. Hide the axes. I've been drawing green dots on the vertices because we all need to know where the vertices are. Obviously, this is not the best way of showing it, but I suppose it's if you just look at the green dots and kind of unfocus your eyes, it gets you a fairly good idea of where they all are. And if I just add in a few more, I'd like that green color back, please. What size was it? 30? 30. And if I add one here, one here, one here, 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 here. So these are the ones that we don't really need. Essentially, these are the coordinates. Well, these are the vertices that are going to be possible in the grid, but we're never going to use them because they're not part of the hexes. What else are we missing? We're missing this one, this one, this one. Here, here, and here. So this is just your standard grid. If you just look at the dots, that doesn't help. All right, what if I draw a line? What if I draw like an average line? So like this is one row, this is the next row, next row, next row, and this row. And then you can see those should all line up. You've got this one, this one. These are very wonky lines. But you can see the points they're going through, right? So it does end up forming a grid. How does this look with the ooh? Okay. Not the clearest representation. How about we do vertices, chords, and then we can just do. That's still 10. Okay. This is 0, 1, 2, 3, 4. All the way through to 10, and we have the exact same going down here, 0 to 5. Now, I see the grid it's making. Excellent. See, you don't need to know programming. I just need to draw better. That's all it is. And this is how we're going to represent the dots. So all we need now is a mapping from the hexagon coordinates to their vertices, their corners. Now, one of the important things to note is you can get the corners, the coordinates of all the corners of a hexagon just by having one of them. So if you know you've just got this top left coordinate, for example, this would be 2, 0, this will be 3, 0, 4, 0, and you also know you've got 2, 1, 3, 1, and 4, 1. And that pattern is consistent starting from the top left, going top left, top. I mean, you can do it in any order, I suppose, but if you start from the top left, the top middle is just going to be the x coordinate plus 1, and then x coordinate plus 2 for the top right. The bottom left is going to be the y coordinate plus 1. Bottom middle is y coordinate plus 1, x coordinate plus 1. Bottom right is y coordinate plus 1, x coordinate plus 2. So it's the same pattern for whatever coordinate you start at. Now, the tricky bit, but I'm just astonished this actually worked out, is you can convert from one to the other. So, for example, if we start, or basically the point I was trying to make there was all we need to get is a mapping from the hexagon coordinate to the coordinate of one of its corners. In this case, we're going to be going for the top left corner. So let's take, what have I got written down here? Let's take Let's take 4, 1. So we've got the hexagon coordinate 4, 1, which is this one. And you can see its top left coordinate is 7, 1. So its corner coordinate is 7, 1. Right? And let's also take 0, 4. Let's actually do a curve there. 0, 4. That is this one down here, and this coordinate is 2, 4 for the corner. So for both of these, you can use the equation. So if on the left-hand side you've got x and y, let's call the other coordinates u and v. Let's give that a little tail there so you can differentiate it. The equation is u equals 2 times x plus, minus 1 plus y. And then v, very simply, is just equal to y. So the second coordinate of the hexagon is always going to be equal to the second coordinate of the top left corner. So we take this one in the middle. Second coordinate is 2. This second coordinate of the corner is also 2. So that's very simple. That's really handy. This one, if we have, let's do these examples. So 4, 1, the x coordinate is 4. To get the x coordinate of the corner, we do 4 minus 1, which is 3, times 2 is 6, plus the y coordinate. In this case, the y coordinate is 1. 6 plus 1 is 7. There we go. Get the u coordinate, or the x coordinate of the corner. And that works for whatever hexagon. So when we were looking yesterday, I think we found 2 equations, one for the top half of the hex grid and one for the bottom half. This works for any hexagon in the grid, and it also has an inverse as well. So just rearranging this equation here, I mean, you don't need to rearrange v equals y, it's just y equals v. But rearranging the equation for u, you get x equals 2 times u minus... No, I'm looking at the wrong equation. Sorry, excuse me. You get x equals... I thought it looked similar. 0.5 times x minus y plus 1. Let's not write too much like a newly born child. So obviously this is the same as over 2. But 0.5, just because, to be honest, that's how I'll probably write it when we code it. But as you can see, if we go back from 7 to 7, 1 to 4, 1, that should be a U. And I suppose this is actually V, isn't it? That looks awful. U is 7, V is 1, 7 minus 1 is 6, times 0.5 is 3, plus 1 is 4. There we go, we've got our mapping from hex coordinates to top left corner coordinates and the reverse. Liam, hello dude. He returns. I know, I came back on Sunday, made my return. I don't know if I'll go back to playing games on stream. Maybe if we just fancy a break or something at some point, or just fancy doing a gaming stream, but I think I want to focus primarily on doing coding streams, because somehow I managed to do a 3.5 hour stream just doing coding and it felt like nothing, as opposed to doing a 3.5 hour gaming stream and feeling like death afterwards. How are you doing though? So hopefully that is clear. Unfortunately, I haven't had time to work out the how are we going to store the edges, but I mean, as I said in the last stream, the edges are they can be stored as just two sets of coordinates of the corners. So for example, let's get rid of let's get rid of that. This edge here, give me the red. This edge here, or if we do it like that, this can be stored as just the coordinate of this corner and the coordinate of this corner. So you know, I mean, that's all the edge is the line between those 2 points. The question is how efficient, well, how we store that efficiently. However, I'm thinking maybe we just go ahead and accept it'll be inefficient for now, but actually get something that works. That might be the best solution rather than spending ages planning this out and maybe coming to a better solution, but maybe not. Maybe it's better to just do it inefficiently, get it working, and if it is too slow, then we'll come up with a better solution. I suppose the final thing we've got to think about storing, I think it's the final thing, is the piers, or the ports. That's what they're called, ports. Which again are just it's essentially 2 points on a hexagon. So that's actually probably the best place, or best way to store them. I'm thinking about where to store them as well. Do we store them as part of a hexagon? Do we store them as just a list? Maybe just a list would do. And I suppose, this is probably getting too deep into the weeds here, but once you know what hexagon or what settlement is on them, you don't need to check again because the settlements can't disappear. Anyway, maybe that's something we think about a bit later. But for now, I did make some changes to this, and I added some tests as well. So I'll give you a bit of an overview on that. So this was the first thing I did, was fix the initialization of the board tiles. I implemented that 2D array that we were just talking about for the hex tiles, and what else did I do? You ever just stare and see red and green, but not what's actually being said? Yeah, me too. You can probably read through this yourself if you're truly interested, but actually, let me just look at the code. That'll be much clearer. I think one thing I did notice was we do need this 7 here. We just set it to 0 because obviously there are no 7s, so we just set the number to 0, and that made it easier. We can loop through all the tiles in the hex grid, 2D hex array, and we've also got to check whether the hex we're placing is actually on that grid. So you remember I said if we go back to here, there were hexes here, that couldn't be placed. So those are coordinates 0, 0, 0, 1, 1, 0, 4, 3, 4, 4, and 3, 4. So all we need to do is make sure the x added to the y coordinate is greater than equal to 2, because if it's not, it's going to be one of these three. And also make sure that the sum of the x and y coordinates are less than or equal to 6, which is, if it was 7, it would be one of these three, 7 or more. So that is the rule that we've just implemented here. I don't know if this is specifically true. I just assumed. I haven't checked it at all. Very bad of me. But the board length, I set the board length as 5, just relating to how wide it is across the widest part in terms of tiles. 6 is one more than 5, so maybe board length plus 1 is true. I don't know. My main thinking for doing that rather than just specifying 6 was if for whatever reason we ever want to expand the Catan board and do like a massive one, which could be interesting. But just to potentially have that functionality there. Obviously, it would take a lot more changes than just a few things like that, but why not? Why not? What else? I don't like these while loops, particularly. These do while loops, because it does feel like this. It's obviously got an end condition, but it's picking a random number, checking if that number can be used, and then using it if it is. If it can't be used, it's selecting a different random number, which could be the same number. It could be another number that can't be used. And so you've just essentially got to wait until it picks the right number. Now, because we've got such a small selection, it doesn't matter. It's going to take, it really doesn't matter about the time that it's going to take to pick a number that can be picked. But I also don't like the way we've initialized these. It's just too hard-coded for me, I think. But then again, I think we can leave it for now. One of those cases where we leave it for now and we clean it up later, right? It's always the case. We'll clean it later, add it to the backlog. But yeah, I'm not particularly a fan of it. However, it does work. Because, where are my tests? Here they are. I'm using XUnit for tests, because that's what I use at work. It's the one I'm familiar with. And I've written 3 tests here. One to test that when the board is created, those 6 tiles that shouldn't be hexagons are still null in the array. The next test ensures that the correct number of each resources in terms of hex tile types are all created. So it'll create the board, then get the list of, or the array of tiles, loop through them and count up the amount of each resource. And we've got the expected values down here. And finally, we have the same thing, but for the activation number counts as well. So we can just go ahead and run all of these, and you can see there we go, it'll pass, all green. We love all green. Perfect. So, what is next? I suppose now we know what we're doing, more or less, with the vertices. We can try and implement this settlements and cities array. So I think, again, I'm going to turn this into a 2D array rather than a list. And we can initialize this here. Settlements and cities equals new Catan building. Now, how How do we work this out? Is it the case that the number of x coordinates is... no, because it's... Is it board length plus 2? Sorry, board length times 2 plus 1. And then just board length plus 2 plus 1 plus 1. Would that be the case for other size boards? For example, if we just got rid of that. Now, that doesn't make another hex board. If we had one that was 4 wide. That looks better. Is that not what we had before? Is that not the same as crossing out that? No, it's not. Anyway, cross out that. We've got this board here. 4 across. How many vertices would we need? Well, I suppose we'd need... So this is index 0. 0, 1, 2, 3, 4, 5, 6, 7, 8. 4 plus... 4 times... that's just 4 times 2. Wait, no. 0, 1, 2, 3, 4, 5, 6, 7, 8. Which is 9 because we started from 0. So it is 4 times 2 plus 1. So that seems to... hold up. And vertically... Vertically is a little weird because we've actually got the same. Because we've only taken this away. This side, or we've only shrunk the hex grid on its, I suppose its x axis. So we've still got 1, 2, 3, 4, 5, 6. Which is the same as we had before. But then again, does this count as an even hexagon? I feel like we're getting too off topic here. Does it matter too much? No, not really. Let's go back. Let's just say... Let's hard code it. Well, we know... No, let's hard code it. Let's hard code it. So this is... What was this? 11. And this was 6. Great. Perfect. We also need to initialize. Let's make a new method. Initialize settlements and cities. So all we need to do is loop through them. We also need to make sure that... yeah, we need to figure out which coordinates are not going to be possible as a settlement or city. So as what I said before was, yeah, these down here. Just grabbing something to eat. We'll be back soon. No worries, Nat. I know you sent that a few minutes ago, but... where's the cat gone? I think we'll be alright. I'll check up on him in a few minutes. Oh, actually, it's 9:30. I should go and check. I'm just going to check with my food orders arrived. I'll be back in one moment. Hello, we're all good. Cat is on the bed and food shop hasn't arrived yet. But I do need to keep an eye on my phone just to make sure. Right, where were we? Out of the flow again. Right, these corners. So I suppose we can maybe use the same... Actually, should we write down the coordinates that we aren't going to use or shouldn't be settlements? So we have 0, 0. We have 1, 0. And we have 0, 1 as before. We also have, if we look in the bottom left, we've got 0, 4. We've got 0, 5. And we've got 1, 5. We've also got, in the top right, 9, 0. Got 10, 0. And we have 10, 1. And finally, in the bottom right, we have 10, 5. Ten, 4. I missed that one. And finally, we've got 9, 5. So is there a way... What are the rules we can use to specify these? These are going to be a little tricky. A little more convoluted. I'm back. Welcome back, Nat. What did you have for food? How are you finding the new job? I'm loving the new job, thank you. Lots of variety. Nice people. Really can't complain. Yeah, I mean... Dream, really. Obviously, there are always going to be days where you're like, I'm not feeling it today, but most days I just really enjoy it. So, yeah, it's great. You had pork and peppercorn sauce. Oh, that sounds delicious. I'm very jealous. I don't know what we're having tonight. I'll be cooking. Charlotte doesn't get back until probably 10 from work. So I don't know. Not sure what to make. I'll have a think about it. Oh, pork and peppercorn sauce. That sounds delicious. I'm very jealous. So 040515. We can't do like adds up to 5 or whatever. Or must be less than, you know, whatever, because it doesn't work like that. That will only work for anything that way and that way. This is getting way too messy. I don't like it. Maybe we just specify those coordinates. Again, I don't like hard coding it, but for now it seems like potentially the simplest solution. For these 3, we can do some of the coordinates must be... some of the coordinates must be greater than or equal to 2 for valid coordinates. And same with these end ones, we can do valid coordinates must be x plus y must be less than or equal to 13, I believe. So if we take this one 9, 4, less than or equal to, yeah, so that adds 13. I believe, yeah, 8 plus 5 will add up to 13 as well. So that's fine. Well, actually, surely we just find whatever the equation of this line is. If we think about this as this line, think about this as, you know, an actual graph. What is the equation of the line? So it's this one, isn't it? It's right here. So it goes through 8, 0. Where does that cut the... the y-axis? I feel very stupid right now. I've done so much maths in my life, and yeah, I'm struggling to figure out this, the equation of this. Well, it should just be this line plus some value, I think. So, for example, we need the equation of this line, which is going to be, so you got y equals mx plus c, y equals minus 1, I guess. Minus x plus 3. So y plus x must be less than or equal to 3. That can't be right. Let's write that down. So this one is... Oh, because... No, we're going the wrong way, that's why. This is positive x. So y equals minus x plus 3. Hang on. No, it's plus... Yeah, plus x. Is that not what I did before? Y equals x plus 3, and then so y minus x equals 3. So we've got y minus x is either greater than equals 3 or less than or equal to 3. Y minus is less than or equal to... No, hang on. Let's do this one. 4 minus 0 is 4. Must be greater than equal to 3. Hang on, but 2 minus 0... What am I doing wrong? Let's just code in these simple ones. Clearly, I've had a long day. If I plus j is greater than equal to 2, that's correct. And I plus j is less than or equal to... what do I call it? Settlements and cities. Settlements and cities. Can I get... Can you pass in like 1 here? I don't usually work with arrays, to be perfectly honest. It's long length. Because the total number of elements in all the dimensions of the array. That's not what I want. I just want... I suppose I can just do dot length. Oh no, because there's nothing actually in there. That's probably why. I'm going to hard code it. So that has to be less than or equal to... Did we say 13? I want to say 13. Nine plus 4 is 13. Yes, 13. Less than or equal to 13. Okay, and then we also want whatever these boundaries are here. So this is just y equals minus x plus 2 is this line here. This one is y equals... This must be y equals minus x plus 13. 6, 7, 8, 9, 10, 11, 12? Oh wait, hang on. Cross it 5, 6, 7, 8, 9, 10, 11, 12. Should it be 12? Or should it just be greater than... I'm going wrong somewhere, and I think my brain is just not in mathsy graph mode right now. Let me draw it on a piece of paper. In fact, let's be sensible and do it so everyone can see. Graph. Can actually do a straight line, so let's do that. So 0 to 10, I suppose it is, and 0 to 5. Well, let's actually do 10 there. 5 there. So obviously this is x equals y, roughly, if 5 equals there. That's actually not bad. And this would be x equals y plus 5. Or y equals x plus 5. So was I looking at the wrong... If we go back to this. Which one was it? This one. This is the... This is the x-axis. This is the y-axis. That's right. I think. Yeah, definitely. So we just flip this upside down. And this is a line starting at 3, going up. So, like before, it's just this line, which is y equals x plus 3, which is, I'm pretty sure what I wrote, y equals x plus 3. The other one was y equals minus x plus 2, which is going something like that. Is it because this is open? This is like an open line. So you can't actually bound anything with it. Whereas the other one, which was, so you got y equals minus x plus 3, which is that one, you bound this area. Or maybe I don't know what I'm talking about. And y equals minus x plus 13, again, just goes like that or whatever. Kind of, you bound this area, whereas this line and this line, whatever this comes to, that's going to be starting at minus something and going kind of like that, is also not going to bound anything to like an axis. So that's just an infinite area there. So these are the coordinates we want in here. So we should be able to do that, surely. If because we've got this bounded area. So we've got it's greater than x plus y is greater than or equal to 2. We've got it's less than or equal to 13. Then this is an x plus y line, so you get maybe x minus y, or y minus x equals 3. Maybe y, maybe if I just stop saying y over and over again, I minus j must be less than or equal to, do we want less? No, we want more, we want greater than or equal to 3. But does this need to be Should this be the absolute value of that? Let's go back and have a look at our numbers again. No, actually, yeah, this is the one we want. So what's this? This is 0, 3. That should be 1. I was looking at the hex chords, wasn't I? I was looking at the hex chords. Maybe that's why it wasn't working before. Yep, I was looking at the hex chords. 0, 3 minus 0 is greater than or equals 3. 4 minus 1 is greater than or equals 3. 5 minus 2 is greater than or equals 3. I was right the first time! Just my messy drawing got the better of me. Okay, that's good to know. Which means also we just need to figure out where this line intersects, and it should be if this is crossing. Let's yeah, that's right. So this is 8, 0, which means this will be 7 minus 1, 6 minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. It crosses at minus 8. So we've got y plus x equals minus 8. Sorry, y equals x minus 8. So y minus x should be less than or equal to minus 8. I minus j should be less than or equal to minus 8. For example, we have 8, 0. You know what? I probably should have seen that, but 8 is the x coordinate, 0 is the y. 0 minus 8 is minus 8, which is less than or equal to minus 8. Greater than. 1 minus 7 is minus 6. Yes, it should be greater than minus 8. And this should be y minus x. Wait, no, x is... Are we doing x is I? X is I, so y minus x is greater... y minus x. Let's look at this point. This is inside. 1, 3. 3 minus 1 is 2. Therefore, it must be less than or equal to 3. This is j minus I is greater than or equal to minus 8. Right, I am an idiot because I've done it on the wrong one. However, that's not too much of a problem. You can just copy and paste that across. That is it. We've bounded it. So we want this to be a new and building. Do we have... Oh, we've got a player color.none and a building type.none because there are no buildings on them. Tiles. Oh, this should be settlements and cities. That's what you get for copying and pasting. Right, so that is the initialization of settlements and cities. Again, we probably should have written the tests first if I were to do proper test-driven design, but we'll do them now. So a new test, and we will call it. Well, it's again part of the create Catan board. What do I call the top one? Empty tiles are null. Let's do empty settlements and cities are null. And let's copy this. Except we want settle. Oh, sorry. Can just rename this settlements and cities. Board. Oh, we need a new method to get. We've got one to get tiles. Let's put in one. Public Catan building. We want the array of that. Get settlements and cities. And we're going to return settlements and cities array. Again, like this get tile, want to get a specific tile or a tile at specific coordinates. We're going to want a specific method to get a settlement or city. Settlement or city. It'll do, I suppose. Let's do int x, int y for the coordinates. Settlements and cities at x and y. Didn't I have a coordinates? I did. Did I actually use this? Maybe I should be passing in a coordinates object. Is that needed? I'm not sure it's needed. Well, maybe eventually we'll switch over to that, but for now I think we can just pass in x and y and that will be fine. Get settlements and cities. And let's get up the list. So it's 0, 4. That's better. 0, 4, 0, 5, 1, 1, 5. And let's copy and paste this so we've got the right number. 9, 0. 10, 0. Or was it 10, 1? And then we've got 10, 4, 10, 5, and 9, 5. Right, let's run this and pray. Oh, that is my food order. I will be right back. Sorry about that. Just had to get everything brought in and into the fridge. All done now. Should be hopefully no more interruptions. We'll see how Chester the cat holds up. I am pleased to say our test passed. There we go. So we can actually... got slightly out of breath now. If we just debug this, we can have a look at this array that comes back. Settlements and cities. So we've got 0, 0, 0, 1, 0, 4, 0, 5, 1, 0, 1, 5, 2, 5. Oh, 2, 5 shouldn't be null. 3, 5 also shouldn't be null. That's a lot of values that shouldn't be null. Right, so that's partly just a bad test. Strange. Right, so there's obviously something wrong with our logic. Let's go back to the board. J minus I is greater than or equal to minus 8. Which is y minus x. Well, I suppose 9 minus 0 is... oh, sorry, 0... 0 minus 9. That would be, because that's y. 0 minus 9 is not greater than minus x. Because minus 9 is not greater than minus x. Which is good. So those should be null, which is why the test passed. We know those are null. It was, I think, some of these values down here. 4 minus 7 is minus 3, which is greater than minus 8, which passes. 4 minus 7 is minus 3, which is less than 3, which is also right. So if we go down here, 5 minus 1 is 4, which is not. 5 minus 2, that does pass. So why does some of these not? Is it a problem with this line? Five plus 7. It's 12, so did I put 13? Maybe that should be 12, but even so, that should be letting more in than we expected. Ah, that'll be why. Another copy and paste error. This should be going to 11 and this should be going to 6. No. Yes, 6. Let's try that again. So just hadn't iterated through all the possibilities. Right, let's have a look at the board again. Settlements and cities. 1, 5. Ooh, let's get our list up again. 1, 5. That's more like it. Look, more filled in. 9, 0. 9, 5. Yeah. 10, 0. 10, 1. 10.4 and 10.5. Perfect. So maybe, can I be bothered to? Realistically, we should assert that everything that isn't these is not null, but I don't know if I can be bothered to do that. Honestly, we know it works, so I think we're going to leave it there. Leave it how it is, and we can commit those changes. At settlements, at cities, array, initialization. And by the way, I have put the link to the GitHub repository in the description. So you should be able to see that while the stream is live, I believe. To be honest, I don't really watch streams on YouTube, but I'm pretty sure you can. And you'll definitely be able to see it when the stream becomes a VOD afterwards on my channel. I also have the link to my GitHub on my actual YouTube channel as well, so you can access it through there. All right, made a little bit of progress. Took longer than I expected though. It's taken a whole hour to do that. But that's okay, it was slightly more complicated than I thought, but we should have it implemented. Maybe it is time to implement converting between the two. What's the best way of doing that? Maybe just thinking whereabouts to put this logic. Initially, to me, it makes sense to put it with the board. You know, maybe make another method in here that's get tile settlements and cities. Settlement and city coordinates? Or maybe just the settlements and cities. Do we need the coordinates? Maybe just straight up get the settlements and cities. Let's add that. This is going to return a list of Catan buildings. Let's just make a list of Catan buildings. But no, that's fine. We don't need to know. We don't need to know whereabouts. Do we even need this logic right now? I don't think we do. Maybe we just implement it when we need it. Just bearing in mind. Let's do a private method instead. Let's do I feel like it should be a static method. Or that we shouldn't need a board initialized. Or maybe we should because no. maybe we'll leave it for now. Leave it until we actually need it. And then we'll think about how we're going to store the roads. So the roads, we need to store them in a way. I mean, maybe we could just store them in another array and map them to the corners. Because I thought about this last night. The roads don't need to know about the hex tiles at all. They don't relate to each other. The roads only need to know where other roads are, and which roads they're connected to, and where the settlements and cities are. Or is it possible that we store the roads as branching off settlements? Maybe have like a for each settlement location, we have a list of I was thinking a list of points that you go through, and that tells you where the road goes. However, I think the roads are just a bit convoluted for that, or they can be. Unless we just store them, as I said, all in a single one-dimensional list, where each road has the building it is, and then 2 sets of coordinates. So corner 1 and corner 2. Let's try that. Let's try... So we're going to want a road. We can probably inherit Catan building, actually. Okay. Where are we looking? Class, new class. And we're going to call it Catan Road. Which also means if we're inheriting it, let's get Catan building up again. I believe that can't be sealed. Catan building. Yeah, it's sealed. So Catan Road is a type of building. Right. Which means it also needs to have a constructor where it takes a Catan player type. I think I need to import this. I'll call it Catan common, that's it, dot enumerations. Catan player type? Was it Catan player color? That's it, Catan player color. Color. I'll just copy this. the Catan building type should just be set automatically. Public overrides, Catan road, and then do we need an argument given that corresponds to the required parameter color of that? I don't really want to have to implement this. Maybe, what if I just do public Catan building and make a new one and have this just set this dot color equals Catan player color dot none, and this dot type equals Catan building type dot none. And then we don't need to override that. We can just have this passing in a color, and this dot cal. Oh. Does this need to be protected? This dot color equals color that's being passed in. Read only field cannot be assigned to. Well, I know that. Okay, there we go. And this dot type equals Catan building type dot road. There we go. And we also want, we are going to want a read only corner, first corner coordinates. Oh, that needs to be of the coordinate type. Second corner coordinates, and this actually needs to pass in those. Wow, read my mind. Look at that. Just change the capitalization on that. In this and this to reference this object. I think that's fine. Clean that up. So if we go back to the board, what we are going to do is the roads, we are just going to make a list of Catan road. Okay, now we need to initialize. Do we need to initialize the roads? We need to know where roads can be placed, the corners between which roads can be placed. For example, at the moment, we can have a road that goes from here all the way to... Why can't I... Oh, there we go. From here all the way to like here or something. Or, you know, down here. Which is obviously not what we want. We want a road from here to... Well, from here to here. Or from here to here. From here to here. Like that. But we cannot have a road that crosses a hexagon. So, is there... there actually may be a simple solution to this. The difference in the sum of the coordinates must be 1. The absolute difference. For example, from here to here, you are going from 1, 1 to 2, 1. 1 plus 1 is 2. 2 plus 1 is 3. That's a difference of 1. From here to here, you're going from 1, 1 to 1, 2. Same difference. Let's do another one. Here to here. I mean, it's always going to be a difference of 1. If you go back this way, it's going to be from 5, 3, which is 8, to 4, 3. Obviously, a difference of 1. If you were to go from here to here, which is not allowed. Actually, it might be nicer if we got the hexagrid on. Maybe not. All right, let's take this. Oh, I wish I hadn't drawn this red grid on here. Okay, we'll leave it on. But obviously you can't cross this hex. You're going from 5, 3, which is a sum of 8, to 4, 2, which is a sum of 6. And the difference between those is 2, not 1. So, simply enough, we just need to make sure that you only change by 1. Maybe we can put all the coordinates in. We just loop through the settlements and cities. We loop through the settlements and cities, we add and subtract 1, so 4 directions essentially, to each of the corners. Let me get these back up. There we go. So if we have this corner, we need to go that direction, not that direction. That is a flaw in my plan. You can't go up there, but you can go up there. And same, actually no, not same going across. It's only these vertical ones. So I suppose that's only the case if the x coordinate is odd in this case. Again, I don't really want to oh no, because it is the x coordinate is not odd here, or it is odd here and you can't cross there. So maybe it's the how do we work this out? If the x coordinates, or if the lower, the minimum y coordinate of the 2 points you're moving between, if that is even and the x coordinate is even, then you can move. If it's odd, if the minimum value of the y coordinate of the 2 corners you're moving between is odd, and the x coordinate is also odd, then you can also move between them. So that's an additional rule. Okay, I think we can do that. Let us make a new private method. Initialize roads. And we want to do a check here if well, we just want to make sure that I suppose settlements and cities isn't null. Make sure it is initialized. Or if it is null, then we'll throw new. Is it an it's not really an argument exception. We'll just leave that for now. So again, we're going to want to copy this because we're going to be looping through all of the settlements and cities. This can just be if, or let's do var corner. I'm kind of regretting calling it settlements and cities. Can we rename it to just settlements? I think I'd prefer that. Or houses. Settlements. Or buildings. No, because we've got Catan building, which also refers to road. We'll call it houses, as much as it kind of pains me to. Initialize houses. Bar houses. Bar house equals houses ij. I think we also need to change it in the tests as well. Yeah, here. House. Houses. Oh, and we need to change this as well. Can we just do it from here? Get houses. And the final one, there was another one. Get house. Right, so settlements and cities are now houses as a collective. If house is null, we'll just do is get is null, then continue. And what do we want to do? We want to for maybe we want in coordinates. Maybe we want this to be a class, and then we can have methods for adding and subtracting coordinates. Private. Ooh, no, we'll make it public. That's gonna, just for convention, that's gonna have to be capital X. Which means we may have to change some things. That's fine. Int X and int y. Unless we just stick with what we have been doing, make these private and get specific getters and setters for them. It just seems a bit of a hassle to do that though, but we'll see. This dot x equals x. This dot y equals y. Now we want a public int get x, or maybe we just call it x, and we return this dot x. I'll call it get x. Look in get y, return this dot y. Great. And we also want to do a public static coordinates add. And we want to take two sets of coordinates, C1 and coordinates C2. And we want to return new coordinates C1 dot x. Oh, I think it'll let us access that. C2 dot x, like that. And then similarly, we can have a public static coordinates subtract. Is it going to fill it out for me? Ooh. See if it comes up with it. No, it's going to make me do it. Okay, C1 dot x. Oh, so because subtract depends on which order they're in, we're going to do subtract C1 from C2. Dot x. Oh, hang on. C1. There we go. We now have add and subtract for coordinates. Add coordinate maths. Nice. That's fine. Looks good. Right, where were we at? We were at Catan board, and we wanted to... I think what we want to do is add a list of coordinates that we loop through and add to each one. So we can do that up here. We can do list of coordinates, road vectors. It's new. So we want a new coordinates, 0, 1, new coordinates 1, 0, new coordinates 0, minus 1, and new coordinates minus 1, 0. For each we'll do vector in road vectors. We also need the road coordinates 1, or road corner 1 equals new coordinate ij. And we're going to want road corner 2 equals coordinates dot add vector and road corner 1. And then we're going to make a new road. Road equals new pan road. We don't want any color. We want road corner 1, road corner 2. Finally, we want to add that road to roads. Roads.add road. But we don't want to add it. We only want to add it under our special conditions, which is if if math.min. Chester, what have you done? Oh, you're not meant to be jumping, you. You're a silly boy. I wasn't paying attention. Okay, you can sit up there. Just don't jump down again. I'll come and lift you down if I have to. Ugh. What a pest of a cat. Just jumped up on the windowsill. Right, road corner 1 dot y. Get y. Road corner 2 dot get y. I'm already regretting using these. So we want, if the minimum of that is equal, divided by, no, modulo 2 equals the x coordinate evenness. But we only want that if it's a vertical movement. Equals road corner. We'll do road corner 1 dot get x modulo 2. If it equals that evenness and vector dot get y does not equal 0. That's not correct. Or vector y equals 0. So if if it's just moving horizontally, the horizontal ones are always going to be fine as long as... Oh, road corner. We also need to make sure the second coordinate is not null. Bool is let's move this to a separate function. Private bool is valid road corner. Do I actually want to pass in the houses array into this rather than just using the global variable? I think I might do. Yeah, I think I'd prefer that. Potentially. Or not. Let me think about this for a moment. Sometimes just by the nature of streaming and having to talk constantly, it's quite difficult to think about what you're actually writing. Right, so we want to make sure the actually we could just do continue. If it is null, that's right. If the house at the second coordinate is null, then that's not a position we can place a road either, or connect a road to. So we don't do anything for that one. And then we do this. Karu, hello, welcome in. How are you doing? If you've just joined us, we're currently trying to work out valid road placements based on the corners we've got on our grid. So these are valid. That is not valid. No, that's not valid. Yeah, that's right. So we want if the smaller of the two values it's going between is even and the x value is even, then it's fine. A indeed. Right corner 1 get y, right corner 2 dot get y. So it gets the smallest y value of the two of them. If that is even and the x value is even, if that is true, then it knows it's fine. Or if it's just moving horizontally, it is also fine. That looks good. Do you do it in Unity/Unreal or only in Visual Studio? I'm only doing it in Visual Studio at the moment. I did consider doing it in Unity, but as I want to focus on just doing the back end, and eventually the aim is to make this into a web API so that front ends can consume this API to play games of Catan. I thought I'd just do it in Visual Studio for now. But I honestly, I would love to do it in Unity or something similar, just for the visual aspect of it, because obviously just watching a load of code, if you are unfamiliar with reading code, or specifically C#, it can be a bit off-putting. But hopefully for those who enjoy coding and know C#, or even if you don't know C#, just know programming, this is vaguely useful for you. All right, that should be the roads initialized. Initialize roads. So let's do some testing. How are we going to test this? That's going to be a little tricky. I suppose we could do, let's write a test. Public void create Catan board. Road coordinates are all valid, or let's do individual road coordinates are all valid. So we'll make the board, and we want to, what do we want to assert? Well, for a start, we don't want the houses. We want roads, which means we also, I've forgotten again, we need to make a method to get those. Public list Catan road, and we want get roads. We want to return roads, exactly. Ooh. Now we can get an individual road. Potentially. That's the other thing we've got to think about, is figuring out how long is the longest road. How do we navigate a road that is between more than one corner? So we can figure out that's a road and that's a road, but how do we tell that those three roads are connected in a relatively efficient manner? Good question. Well, for now, let's write that test that we were writing. Get roads for each road in roads. Not equal. How do we? Because we want to make sure that new coordinates 0, 0. We want to make sure that road dot. Oh, we can't get the coordinates because we haven't added that in. Public coordinates. Want to get corner 1. Get first corner. And we want to return first corner coordinates. Maybe get first corner. Just get first corner is fine. Want to get second corner. And return second corner coordinates. There we go. I'm sorry, I'm new in programming. What is backend / frontend? If heard from it, and that you cannot use all languages for both, but what are backend and frontend? You've heard of it, and that you can't use all languages for both, but you didn't really understand it. Essentially, frontend is all the user interface. Generally speaking, the front end is running on the device that you're viewing it on. So, for example, if you're just in your web browser, the front end is going to be something like JavaScript, which displays the individual components of, like the buttons and the text fields. And then if you press submit, it will send that to the backend, send what you put in. Now, I appreciate that wasn't a great explanation, but the backend is what does most of the central processing that is separate from the individual devices. So that will communicate typically with whatever database the system is using, or it'll do any processing. Yeah, any sort of interfacing with third-party APIs. Let's take an example system of. Well, let's do this system. This web API we're doing for Catan. So on the back end, we're building all the logic for the game itself. So, for example, we're doing the logic for a player rolls the dice, and then depending on what's rolled, that player then gets certain resource cards. And all that logic is contained in the back end. And if we wanted to store games or save games that could be picked up another time, the back end would also interface with whatever database we wanted to use and store them in whatever form you choose. The front end would be what is displaying the game. So again, you could use something like JavaScript. The front end would make API calls to our web API and send requests like get board state. And then our backend web API would return the board state to the front end so that the front end could then go, okay, this is what it looks like, and I'm going to display it like this. So the front end then has complete freedom to display that information as it wants. I hope that makes sense and helps your understanding of it. There's probably much clearer explanations out there, since I didn't really put too much thought into that and had to do it off the cuff. But yeah, I hope that helped. And yeah, if you do have any more questions, I'm more than happy to answer them. Right, so we've got get first corner, get second corner. So you only need the backend if you want to save or multiplayer. I mean, you could definitely implement the same. So in the same example, if you were doing a game of Catan, you could definitely do all of the game logic on the front end as well. a big consideration is also the power of the processing power of the device that you're using. So if you're making a mobile app, for example, if you do all of the logic on the front end and don't have a back end, then your phone has to do all of the processing. Whereas if you have a back end, that's usually on some server elsewhere, or in the cloud, which is a server elsewhere. Then you can send off requests to the server, and the server does all the processing, which means less load on your phone, and it should extend. Well, it won't decrease your battery as fast because your phone's doing less processing. But to answer your question, you need backend for various things. But yes, if you want to store information that can be accessed by multiple devices, then yes, you do typically need a backend. So multiplayer, from my understanding of multiplayer servers, well, that's exactly what it is. A server is a backend. For example, if you're playing an FPS game, you would typically join a multiplayer server, and that server would store the actual state of the game you're playing. So it'd store all the players' positions and the score, and who's firing, where the bullets are, and whatnot, all the calculations. The front end will then get that information from the server. So the server is the source of truth. If it was all being done on your individual devices, it's not always going to be exactly the same on each person's device. I've gone on a bit of a ramble there, but hopefully that's enlightened you a little bit on it. But typically a backend is needed for bigger projects. You could absolutely access a database from the front end, though. I think part of it is also the back end is going to be, it's kind of expected to be running all the time, so it doesn't shut down. Or, it'll shut down for maintenance or to be restarted, but typically it'll be running as long as it can. Whereas the front end, you're going to be closing your browser, you're going to be closing the apps on your phone, and that will get rid of any data that's currently running in that program. Okay, let's road.get can't remember what I was doing. I'm sure anyone who works in software development or other fields knows knows the feeling of when you're really in the flow of doing your work, and then suddenly you have a meeting or somebody needs to chat to you about something, and you finish with that, and then you come back to your work and you go, where was I? What was I doing? You're like a computer being turned off and on. You lose everything that was in your RAM. Got to boot it all up again. I suppose that's maybe a good analogy for front end and back end. Generally, no clue what I was doing. Individual road coordinates are all valid, which means we want to make sure that get first corner. There we go. Okay, that's all we need. And assert dots not equal new coordinates 0 0 road dot get second corner. So we want to make sure that both the first corner and the second corner are not equal to 0, 0, which is an invalid corner. Do I really want to do this for all of these? Yeah, I guess so, just to be on the safe side. 3, 4, 5, 6, 7, 8, 9, 10, 11. I think that's all of them. So we want 0, 1 now. And then we want 1, 0. We want 0, 4 and 0, 5. We want 1, 5. 9, 0. And 10, 0. And we want 10, 1. 10, 4. 10, 5, 10, 4. 10, 5. And we also want one more. 9, 5. Working 9 till 5. Right, okay. I guess we just run this and we'll step through it the first time just to have a look. And insect index was outside the bounds of the array. Nice. Road corner 2. Right. Yes, that is something else. We want to make sure that it's actually within the array as well. That makes sense. Maybe we want to start from 1, 1. We're also going to get duplicates. Because if we're starting at this one with or this one, we're going, like that way, and that way. Then when we get to this one, we're also going that way, and up. So this one is duplicated twice. Or it's duplicated. Oh, okay. Do I want to... Unless we just do right and down, or right and up. That should get all of them. So we can get rid of the minuses. And then we just need to do 10 and 5. So we go to 9, right and down. We will be missing that road. And we'll be missing these roads as well. Thanks, that helped a lot. Excellent. I'm glad to hear that. Sorry to ask so much. No problem at all. I always feel like when you write with a programmer that it's that's live, that it's root to interrupt instead of that it's live to interrupt instead of integrate. I'm not sure what you mean by that that last sentence. That is live to... I always feel like when you write with a programmer that is live, to interrupt instead of integrate. I'm not entirely sure what you mean, but no, feel free to interrupt. I mean, I'm more than happy to ask questions or take suggestions. And you know, it's it's my problem to get back to where I was, so that's absolutely fine. Is my cat still on the windowsill? Oh yeah, you are. Good boy. You're right up there. He's just having a snooze on the windowsill. Does look very cute in his baby grow. Okay, so we want to maybe just test that it's within the bounds. The only Oh, do we need to do the same? No, we just need to test that if it's 11, or if it's maybe we do minus, and then we can test. That's probably the better way. No. Oh yeah. Then we can just test if it's negative, and then if road corner 1, or if road corner 1 is always going to be fine. So it's road corner 2 we want to test. If road corner 1, no, corner 2 dot get x is less than 0, or road corner 2 dot get y is negative, then we continue. That should be fine. How do you test your code? So I'm using something called Xcode, Xtest. What is it called? And no, XUnit, that's what it's called, XUnit. There are, it's a test framework, essentially. So it's basically some code that you add, or that you set up, and it allows you to run tests. There are also others, like NUnit is a popular one, and what's the other one? MS Test is the official Microsoft one. And they all have varying syntax, but all typically fairly similar. So XUnit, to define a test, you do fact as this like attribution tag, or attribute tag. And that will define it as a test, and it'll just run this method. And then you have these assert methods. So this is testing that this value is null. And if it's not, then it will fail the test. So all of these assertions have to pass for it to, the test itself to pass. If any one of them fails, the whole test fails. Same if there are any other just general exceptions. While it's running the method, it will fail the test. And that is the technical actual implementation of how you test, I suppose. Hello, Bears. I remembered to switch account. Why, do you have a different account? Well, we all have different accounts, but good to see you. How are you? How's your week going? But Karu, if you're asking how do you test, as in how
how do you come up with tests, or what do you test? They are more involved answers. There's also when do you test? Do you write all your code first and then write tests afterwards, or do you write your tests first and then write your code so that your tests pass? The second option, which is called test-driven development, where you write your tests first and then write your code afterwards, that is, from my point of view, I think a better way of doing it. But it does typically take longer as well. But I think it's generally you write better code if you do it that way. You got like 4 accounts. Yeah, I've got a few as well. Don't think I'll understand any of this, but it is perfect second monitor content while I do DICE research. Excellent. What DICE research are you doing? I think that's good to hear, because I did think if I was doing programming streams that it would just appeal to programmers, but if you do, I don't know, like the sound of my voice, then maybe it's good background noise. You know, my own partner said she likes when I talk about programming or just like projects I've been working on, because she likes listening to me when she's falling asleep. Now, I don't know if she means my voice sends her to sleep or she just, you know, it's kind of soothing when she's falling asleep. But I do like joking that I've just got such a dull voice that it sends people to sleep. And there's a shop with good deals, but it looks sus as hell. Yeah, I would, I mean, I don't know much about buying dice, but I typically stick to well-established online shops. Well, even well-established physical shops as well. Let's run this again. There we go. So it has actually finished that method. We have 72 rows. Is that correct, actually? Should we have 72 rows? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70. The answer is no. We should have 70. Right, we've got between 03 and 02. X is 0. Yeah, X is 0. 02 and 03. So that's that one. That's good. Actually, let's just let the test run and see if it does pass. Curious. Maybe we have too many corners as well. That would be interesting. How many corners do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Oh, hang on. I've lost count. I heard that if you make a game, you want to have a working prototype as fast as possible. So testing like a prototype.
I'm not entirely sure I understand what you're asking, but I think it's if you have I am not well versed in game development, like proper, 3D or 2D game development. Especially using something like Unity. I've done a few tutorials, but I'm by no means an expert. I have no industry experience either. But I imagine you would want to get a prototype done as soon as possible because it's easier to build on a prototype. If you have nothing, I mean, firstly, you've got nothing to test. You've got to think about all the actual architecture of your code, how it's all set up. Whereas if you've got something, you have something you can test. You can, it's easier to come up with tests for it because you know how the code is going to look and what you're going to need to test it. So I suppose that's one reason why if you get a prototype quickly, you can test that and then kind of smooth it and, mold it in the right way to get something more refined. And then, test it. And I mean, you're going to want to be constantly testing and adding more tests, but you've also got to balance that with actually developing as well. Ask this on your recorded video, but I thought I'd ask here since I saw you were live. I have not seen any comments, so maybe I must have missed that, in which case I apologize. Why are you using custom getters, get resource type, instead of using a property? Honestly, a great question. I'm not entirely sure. I feel like just making these properties private would be easier, especially because this is not going to be a massive program. It's not going to be super complicated. I think the reason, because if you haven't heard this already, I'm trying to kind of gather experience with clean architecture and clean code, and by making these private and making specific getters for them, you can control which properties are accessible and also what they return. Whereas properties, if you make them public, you can easily change them. You can easily access properties which don't need to be accessed. Which, as I think your point is, it's probably not a big deal for a small program like this, but I think because I'm trying to focus on clean architecture, that's the reason I've done it. You can have a get only property. Yeah, I suppose you can, but I think we did. Oh no, we didn't actually make those others public, but oh, actually, that's a good point. I've got a private int with a get and set. I don't actually need those. But no, that's true. That is very true. You can just do that with have a get only property. Do you have a suggestion why they should be public properties? Because again, this is kind of a learning exercise for me, so I'm always happy to hear suggestions. It was like 1 minute ago and I typed it. Got it. That's probably why I haven't seen it then. But yeah, I'm more than happy to answer any questions or take any suggestions. Having public properties is definitely easier and probably more readable as well, depending on how you lay your code out. For example, when I've got, was it in Catan board? Let's just close that for now. This looks pretty messy. For example, if we just had .x, would that? Yeah, I suppose maybe .x and .getX fairly self-explanatory, but I'm not sure. When I
For my work, we do use just public properties, or at least the code that I've worked on. But I think we are moving to using private properties with getters and setters. You have the field private, but then write a public get X property. Yeah, which is basically what a get only property is, just with less lines of code. Yeah, no, I totally understand that, and I see your point. But where is it? Here. Don't need this anymore. Okay. Now, let me just take some time to get my thoughts in order. Because no, this is important for me to think about as well. Is why, what's the reason for doing this? And what is the benefit of having these public methods? The benefit of having the public properties is, as you say, less lines of code. You can easily access the properties without having to use a method. You can access them directly. You can still control whether you can set or only set or get them by just doing, not having the set method or having both, or not having the get method. Can you only have set? Also implemented properties must have get accesses. Oh, shows what I know. And I suppose if you have a class with many properties, it does take a lot of time to implement these public methods to get the properties as well. All of your code for X could just be public int X. Yeah, no, I do totally get that. And I mean, these could probably have a setter as well. We just haven't had a need for it yet. So in this case, I think you might be right. But I think there are also use cases for both styles. But yeah, for maybe a simple project like this, it's probably maybe too much. Slow down development time, make you write more lines of code. So I'll have a think on that. Probably do some research after the stream. Or actually, how about we just have a look now? Public properties versus accessor methods. Let's have a look. I'm going through Stack Overflow now. Right, so you should use properties for anything that conceptually represents the object state. Actually, am I looking at the exposing member objects as properties or methods? Yeah, right, okay. If a class contains a member that is a class object, should that member be exposed as a property or with a method? This is saying you should use properties for anything that conceptually represents the object state, so long as its retrieval isn't an expensive enough operation that you should avoid using it repeatedly. In general, methods represent actions and properties represent data. Yeah, makes sense. Use a property when the member is a logical data member. Name is a property because it's a logical member of the class. Makes sense. Use a method when the operation is a conversion. The operation is expensive enough that you want to communicate to the user that they should consider caching the result. Right, okay. Using the get accessor would have an observable side effect. Calling the member twice in succession produces different results. Order of execution is important. Member is static. Member returns an array. Properties that return arrays can be very misleading. Usually it is necessary to return a copy of the internal array so that the user cannot change internal state. That's interesting. Right, so yeah, I think you've made a good point there, and we should probably just change those to public properties. Private int x and then public int x, get return x. Yeah, no, you can totally do that too. I hadn't thought about that. So you could have public int x and have the... Let's see if I can actually write this properly. Hello? Oh, I was not pressing the right button. Get, it's something like that, isn't it? Return x. Why is it? Can you not do that? Or do you need the, yeah, you need the brackets, don't you? What am I doing wrong? There we go, it's done it for me. No, it hasn't. Do you not need these? Can you just... Oh, that's it. Yeah, you don't need the return. That's why. No return. Yeah. Yeah, so you can just do that instead. And then it's... yeah, it's basically the same thing, isn't it? But you can have custom logic within these gets and sets. So, no, I think you've made a very good point there. And I think we'll change all of these to public. And honestly... that'll make my life easier, to be honest, which in itself should have been a clear indicator that it's the better thing to do. C1 dots. Oh yeah, again, we can just do this. Well, thank you very much for that. Yeah, we'll make these public as well. It's going to take a little while to refactor. Shouldn't be too bad though. Again, this can be public, I think. Or maybe we want a public. Oh, I haven't done the no, that's not the one I was on. What was it? Coordinates. There we go. Can't forget those. I think for now, for the roads, I don't think we were going to want to move the roads after we've set them. So I think we will actually just use get for those, which means we don't need these. And cool. Again, we're going to need fair bit of changing in some other classes. Public type has just get. Same with this one. Change the name. Coordinates we've done. Catan boards. These can be private read-only as they are arrays, which, well, maybe lists are different, but close enough. Make that public. I would like to separate these out a bit. We've got mix. Oh, this can be public as well. Public board length, and that can be set. It's 5. That's fine as private. Catan tile. Type and activation number. Again, I think just need the get accessor. There we go. And we can get rid of these. I think that's everything. Although we will need to... Let's just build and see where the errors are. Oh, blimey, it's 20 to 10. We should probably finish up soon. Which will also give me chance before Sunday. I think Sunday will probably be the next stream. But it'll give me a chance before Sunday to figure out a little more about what we're doing. That's because I'm still trying to use it as a method. Yeah, so current plan, Sunday at some point, we will do the next stream, make a bit more progress. I would love to finally get past all the board representation stuff, because it's pretty dry. And yeah, I don't mind keeping that as a method. Yeah, we can get onto some of the more fun game logic after that. Here we go. Get resource type. So this should just be .type. Dot activation number. Oh. Ooh, no. Oh, actually, you know what I can do? Find and replace that with first corner. Please tell me I called it first corner. I did. I did not. First corner coordinates. Oh, and I haven't changed these. Okay. Second corner. Let's undo that. And first corner coordinates. That looks better. Do that with the second corner coordinates. This, I don't know about you, this name feels too long for just a set of coordinates. Maybe we could call it that. No, I like calling it, being, you know, quite verbose with it. That's fine, we're still doing that. Oh, that's a good point. We can probably place the robber now. Because we know, now we've initialized the houses, we know where the desert tile is. So we could do houses.find, houses. No, because it's not a... Can you do link you with Actually, I'm not sure I've got that even installed, but right, we'll just loop through. Or maybe just when we do oh, it's not the houses, is it? It's the tiles, that's why. Even so, create new Catan tile. If Catan tile type equals desert, we don't actually know the coordinates. They're there. So if we go, if tiles ij dot type equals Catan resource type dot desert, then robber position equals new coordinates ij. I don't really like putting that in this initialize tiles method, because how about initialize tiles and set robber? There we go. It's problem solved. It now does more than one thing, but at least it says that it moves the robber as well. Yeah, I like that. So we've got the roads. We've still got that problem with the roads. We have more roads than we should do for whatever reason. So it's starting here, and it should be going down and to the right. So it should do 2, 3, and it should also do, oh sorry, 0, 2 to 0, 3, and it should do 0, 2 to 1, 2. So let's run this again and just have a look at what it's actually outputting. So this should be 0, first corner 0, 3. Oh no, that's right. That's what we're doing. Yeah, because we're actually checking the negative values. So from this corner would be going, or from this corner would be going up 1 and that way. Neither of those are valid. We'd then move on to this one, would do up 1, left 1, only that one's valid. None would then move here and do that, do here, that, and then we'll move here. So we'll do this one and this one, which are both valid. So we should have those roads next. One, 2, and 1, 2 to 1, 1. 1, 1 to 1, 2, 1. Yeah, 1, 2 to 1, 1. And the next one is 1, 2 to 0, 2. 1, 2 to 0, 2, which is correct. So it looks like it's working. Unless I counted the number of rows that we should have incorrectly. I can't see why we would have 2 extra. Just on a whim, I'm going to look at some of the last few. We've got 10, 3, and 9, 3. Or 10, 3 to 9, 3. 10, 3 to 9, 3. Yeah, that makes sense. We should also have 10, 2 to 10, 3 as the one before. 10, 3 and 10, 2. Yeah, that's right. 10, 2 and 9, 2. That also sounds right. 10, 2 to 9, 2. Yeah, that's right. Should we count these again? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71. We've got a different count to last time. We've got one more. Did I start counting at 0 or 1? Oh no, because if I started counting at 1, then it's incorrect. Oh no, we missed one. 72. Yeah, that's right. I'm pretty sure I started counting at 1. And I didn't. Yes, I forgot to count that one. Right, so I think actually we have the correct number of rows. Hell yes. That was the other thing. I was going to check if we had the correct number of corners as well. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, Han. Let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54. Now, what we can do... certs dot... matches? No, assert dot true. You know what? Let's go back a bit. Not null count equals int not null count equals 0. And then for each house and houses, if house is null, continue, or if house is house not equal null, not null count plus plus. Then we can do an assert dot true 54, not null count. Oh, we want assert dot equal. That's what we want. And this one's a little easier. We can just do assert dot equal 72 roads dot count. So let's run this one. And it succeeded. Excellent. So we do have 54 corners. Did that run? Test finish, one passed. Okay, yes, it did. And we have 72 roads. So that's looking good. It's looking like we have a successful storage, at least, of all of the tiles, all of the corners, all of the roads, and the robber. The ports, I think that's a job for next time. But, you know, pretty much there, pretty much getting there, which is a relief, honestly. So yeah, that's it for today. We will be back Sunday evening, most likely. If not, I'm sorry. I will stream again. I'm still trying to figure out the best schedule. For me, it'll probably be set to 2 times a week, likely in the evenings, UK time anyway. But I hope you found this helpful or entertaining at the very least. And I will see you next time. Have a good evening, everyone, and catch you later. Goodbye.